Okay, so the cosine is 3/7. That means the x-coordinate on our unit circle is 3/7. So is that beyond halfway or closer than halfway? It's a little bit closer than halfway, right? So we're looking at an x-coordinate of about here. So if you look, we have two places where we can form our angle. We have one place in quadrant 1 up here, and we have another place in quadrant 4. Okay, which one is it that we're solving for this angle? The bottom one, right? The one that's in quadrant 4. So here's the terminal side of that, and then the initial side is always the positive x-axis. And so the angle that we're solving for, the solution to our angle, is going to be this whole measure. Okay, so it's this whole rotation here. And now, if we go in and we solve for our theta measure, the theta value that we solve for on this is just going to be the measure here through this other piece. And so this is what the calculator will show us when we take the inverse cosine of 3/7. So let's go ahead and do that. So we know that the cosine of theta is 3/7. Therefore, the calculation we use to find an unknown angle, we take the inverse of that trig ratio inverse cosine of 3/7. So what this is telling us is what angle has a cosine ratio of 3/7? Well, according to our calculator, if we enter that, inverse cosine of 3/7, I'll put a decimal in there so my answer is in decimal form. And this is now, here we can find it in either degrees or radians, so I'll find it in degrees here. And so I get 64.62 degrees. Okay, but that's this angle right here, 64.62 degrees. Okay, but not only is it this angle, it's also the reference angle if we were to create our triangle. So if we create the right triangle and our reference angle, this reference angle is going to be the same exact measure, in this case 64.62. Okay, so how can we come up with this whole angle measure from here to here based on what we know? Well, we know one of two things. We could either say 180 plus this measure, or we could say 270 plus this measure, or since the angle that we have is this reference angle of 64.62, what we could also do is we could come around this whole measure all the way back to the starting point and then come back out to form our whole measure. And so we get the calculation that this original theta that we're solving for is the full rotation of 360 minus this piece that we return back, which is the reference angle 64.62. Therefore, if we take that calculation, 360 minus this reference angle, we get our answer of, again, this here winds up being our reference angle, but the whole angle theta is going to be 295.38.